Okay, so we see here a mass on a spring, and you can observe a tension force in the spring. Observe the changes in the tension force, so it's getting quite large there. Observe the direction of the tension force. It's back towards the equilibrium point, which is about here. Notice that the weight and normal force aren't changing and are basically equal to each other. Notice the tension force goes to 0 right there at the natural length of the spring. We also have plots down here of the velocity of the particle versus time. So out at the end there, it's going to stop and the velocity will be 0. And then here's a graph of the displacement of the particle versus time. And it's a little offset, but when it goes through the natural length of the spring, that should be the 0 of position. And so we're just asking you to think about the velocity and how it changes, and the forces and how they change as the particle moves back and forth. You could see displayed there the velocity numbers now. And so it's worth watching this simulation just to develop some good intuition about changes in velocity and changes in the direction of the force and the acceleration. There's some questions in the text to accompany this simulation, and mostly they can just be answered in point form, a couple of words each. There's another simulation to watch now of a vertical spring. So here we've got a brick on a spring, and we see its weight vector displayed here. That doesn't change. We see the purple tension vector. That, of course, changes as the spring is compressed and decompressed. And then the black arrow is the net force, the resultant force. So up here, this is the rest length of the spring. At this point, there would be no tension in the spring. The mass isn't getting quite to that point. Here's the equilibrium point, and at the equilibrium point, there's no net force, and the weight and spring forces are the same. So you can see that the mass is moving up and down on either side of the equilibrium point, an equal distance. So you can observe how the net force is changing with time, how the other two forces are changing with time, what the position graph looks like over here, and what the velocity graph looks like. You can see as well, when I bring the cursor close, it's displaying the velocity as a function of time, negative being downwards, positive being upwards. And so once again, we just want to have a good feel for how the forces vary throughout the motion, and also what the graphs of position and velocity look like. And once again, there's some questions to answer in the textbook based on this.